All right. So, who got the bell work? Who feels confident? Anyone? How do we say this in words?
The limit of f of x as x approaches 3 is 5.
Perfect, exactly. So the limit of f of x as x approaches 3 is 5. Awesome. Oh, you know what? This this one didn't make sense probably. This was supposed to be f of 3. I need to go change that. So now that we know that, let's look at it again with fresh eyes. So if we know that the limit of f of x as x approaches 3 is 5, but we know that f of 3 equals 2, what's the significance? What does that mean is going on there? The function is 2, but the limit is 5. Yep.
But there's like a separated value.
Exactly. If I've drawn a picture of it, it basically means there's a point of discontinuity, right? We did some like this, where here, that's going to be, say, 5, but the actual function itself is going to be down here at 2. That's what's going on. Does that make sense? Anytime we have the limit and the actual function being two different things, right, that's all it means, right, is that there's something like this going on, some kind of point of discontinuity. It can't be an asymptote, right, because then the function would be what? If it's an asymptote, what is the function?
Undefined.
Undefined, right? It's always undefined in an asymptote. Awesome. All right. So I guess if I put that in words too, it would mean there is a point of discontinuity at x equals 3. Awesome. All right. So let's do some stuff for real now. So what we're going to do is we're going to look at this function here. This function is a rational function. The coordinates of that hole that's there is -3 and 7, 6. Okay? What do we know about this function before we do anything? Let's see how good your pre-calc is. Normally, that's a difference of squares there, right? So if that's a difference of squares, that would mean that there should be two asymptotes. Since there isn't two asymptotes, what do we know happened? How did we turn that asymptote here into a point of discontinuity instead? Algebraically, what happened?
A hole.
Yeah, there's a hole. How do we get the hole?
There is nothing on top.
There you go, exactly. If we factor the top and bottom, it means that we're going to have the factor x plus 3 on the top and the bottom, and they canceled, right? It means that that is still a non-permissible value. It's still a hole in the graph. We can't be -3, but it isn't an asymptote anymore, okay? That's what it means. So let's take a look at this now, and let's compare our pre-calc that we did last year to what we're going to write in calculus, and basically we're just going to get more efficient, okay? So before we even look at the answer, let's write down our notation here. So as x approaches -infinity, the graph of f of x approaches something, and that's what we said last year, or something like it. What does that mean in calculus notation? It would mean the limit as x approaches -infinity of f of x is equal to some value, okay? So let's go up now. Let's look at what those values are. Actually, I'll wait. Y'all right. Yeah.
I think it's as x approaches -infinity, f of x approaches +infinity.
No, not quite.
Infinity.
So if I'm going this way, right, I'm going to get closer and closer to the horizontal asymptote. Okay? So one of the possibilities, whenever we're doing, like, going off as x goes to infinity or -infinity, we have three options. We have a number, which is a horizontal asymptote. We have infinity, or we have -infinity. Okay? So in this particular case, it's going to that horizontal asymptote, so it's approaching 2. Okay? I think what you were thinking, Pedro, is like as we approach this asymptote here. Yeah, and we're going to talk about that asymptote next, okay? So let's do this next one first. As we approach the infinity. So this is the limit as x approaches infinity of f of x. And if we're going off to the extreme right, if you looked on there, what are we approaching? Infinity, -infinity, or that horizontal asymptote? Right, so it's still 2. Now, in these two cases here, and don't worry about it, I'm going to tell you again later, but anytime x is approaching infinity or -infinity, this is what we call end behavior. We're basically trying to figure out what does this graph do if we go, right? There we go. What does it do if we go to the extreme right or the extreme left? We want to know just what is the graph doing, okay? All right, so now we're going to approach that hole that was there. And so it's as x approaches -3 from the left, the graph of f of x. So again, in limit notation, this is the limit as x approaches -3 from the left, meaning we need that little negative up there, of f of x. And it told us, we zoom up just a little bit, what did it tell us that hole was? Where is it? 7/6, right? Now, if I look at this, is it going to approach 7/6 from both the left and right side? Yeah, right? It's approaching the same thing. So the fact that it's coming from the left is kind of unimportant in this particular case. So it's equal to 7/6. If we approach it from the right, it's going to be the same. So the limit as x approaches 3 from the right of f of x is also 7/6. You guys all with me still? Did you say not much? I'm trying to figure out what you mean by not much. No mucho. Means you're with me a little bit. You're not completely lost, but you're not feeling good about it? Yeah? Okay. All right. Can I keep going? Pablo and Amelia, do you need help? Do you guys want me to explain something?
He's asking me about
You're good? Okay, because I don't mind telling you, man. Just ask, right? All right, so the next one, guys, we're going to approach 3. What are we approaching when we approach 3 this time? From both the left and right. We're approaching that asymptote. So first, let's write our function, or our limit notation, sorry. Right? So the way that we show it coming from the left and right is by using those little negative and positives in the exponent, right? And in this case, it could be the same, it could not be. Regardless, if it's approaching an asymptote, what do we know for sure that it is going to happen? Like, there's only 2 possibilities. Where does it go? Infinity or negative infinity. There's no other option, right? You cannot get closer and closer to that wall without, like, bending one way or the other, right? So that's what happens. So let's go take a look here. When we are looking at it from the left, so coming this way, what are we getting closer to? And when we look at it from the right, positive infinity, exactly. So from the left, negative infinity, and from the right, positive infinity. What does that mean about the limit there? What is the limit at 3 then? Which means we say it doesn't exist, right? It doesn't exist because they're going to 2 different things, right? If they were both going up, what would the limit be? Positive infinity. If they're both going down? Good, right? So because they're going opposite directions, there is no limit at that asymptote, okay? All right, so based on what we've just seen then, how could we informally define the value of a limit represented in terms of this particular graph? Well, it's really just whatever f of x or y is getting closer to, right? So let's write it as it is the value that f of x, which is y if you can't think of it that way, is approaching, or like getting closer to. Does that make sense? You're going to hear me say that a lot. So like, what are we getting close to? I think I've already said that to you guys a few times, right? Previously, we wanted to know what the answer was. Now we just want to know, what are you getting close to? Okay? Why might we want to do that? Anyone have an idea? Why do we care about like what it's getting close to? Oh. This is how I know you guys have only done math so far for the sake of doing math, is to predict things, right? The reason we come up with mathematical models, the reason that we do all of this and what we're going to learn in this class is you're going to learn what you did in pre-calc to do it faster and to be more accurate so that you can actually go and figure out what's going on in the future for something, okay? That's the whole reason we do it, right? So like, for instance, with this stuff that we're learning, you're going to be able to, you could analyze like a business and be able to tell them like what price point they should make on packaging in order to make sure that they're saving more money. And we'll do an assignment on that later. If it lines up properly, we'll do it for Christmas and you'll fill it with Christmas treats and get a bonus for the treats. It'll be great. If not, we'll do it in January because you were slow. We'll see. I'm hoping we can do it. Hoping we can do it for December. I find it fits well there. Plus, it gives you a nice break, easy assignment. you know, instead of a test right before Christmas. It's a good thing. All right, limit existence theorem. If the function at x equals a approaches the same value from the left and right, then the limit exists, even if the function at x equals a is different from the limit, or does, let's say, or, yeah, does not exist. So I'll give you a second to write that. I know it's a mouthful. Manuel, did you write this down?
I wrote.
Are you lying? So if I can have a look at that, it's going to be there? All right, show me. I don't believe you. I don't believe you for half a second. Show me. I mean, it's not the same thing, but okay.
It's a resume, so you're not English class.
All right. You guys done?
No.
Not quite? Okay. That's why I'm asking. It's okay. Just because I just met her and I didn't ask her. I was like, I'm pretty sure that was the one that's not been here. And is it's Julieta, right? No. The one that's gone. She's coming back next week or the week at the end of next week? Do you know?
I think I'm
End of next week. So she's missing a whole other week. Well, I guess this video is for her then.
just so you know,
All right, there's enough talking. I think you guys are good. I think you're good. So let's take a look at some of these now. All right, so what we're going to do is we're going to find each of these limits, guys. So the limit of f of x as x approaches 2 from the left. From the left here, what are we going to? Positive infinity. From the right, what are we going to? Amazing, right? From this side, we also went up. What is f of 2? Undefined, exactly. Yeah, it's a vertical asymptote, which means it's undefined.
I didn't understand that one.
yes, no.
It's because you guys are trying to think only about what you're doing now. You can't do that. You got to think about what we've done before, too. If I say f of 2, I'm asking you for pre-calc answers, right? What is the value at 2? Not the limit, the value. There is no value because it's a vertical asymptote, right? So it's undefined. The next part of that is, does the limit exist or not? Why or why not?
Yes.
Yes, it does.
Because of that.
Exactly, right? So remember we talked about like left and right side. So what we could say is that, let's see, both left side, well, let's just, you know what, let's not say it that way. Let's just say left side equals right side. Left side equals right side, which equals infinity. Therefore, the limit exists. Right? Basically, the key here is, does the left and right approach the same thing? And if they do, there's a limit. Okay? Now, obviously, you can use this formal definition we talked about up here, but I think it's easier to just think always left side equal right side, yes or no. Okay?
One is when negative and one positive, then it doesn't.
Exactly. Then it doesn't. All right. So for this next one, limit as x approaches 2 from the left. What is that? It's 2. From the right-hand side, 2. What is f of 2? So pre-calc answer. No.
Undefined.
No.
Doesn't.
Negative 3 this time, right? See, it's got this point of discontinuity down here. Does the limit exist?
Yes.
Yes. Right? Left side equals right side. All right. Which I guess I probably should say left side equals right side equals 2 would be even better, right? So our limit exists. All right. See how we're doing? Let's try the next one. I think you can probably already tell because I'm giving you the pictures, and that's the whole point. Later, you're not going to get the pictures all the time.
Mr. I have a
Okay.
question.
Yeah.
When it's the function where we need to do a breakout, for example, if the answer is negative 3, we're looking first at the black point, but if it's, for example, the limit, the one that the answer is 2, we're looking
At the graph. So the limit, you're always going to look at the graph and see where it's approaching. For the pre-calc answer, you're just looking at that exact point. What's going on there at 2? Okay?
And if there's not an exact.
Doesn't matter. It's like this one. There is not an exact point, so it's undefined, but the limit could still exist. Okay? So for instance, like if this wasn't here, does that change the fact that the limit exists?
No.
Nope. All it does is change the fact that the function doesn't exist. All right, so looking at this one. From the left, as we approach 2, what do we get to? 3. What do we get from the right as we approach 2? What do we get at 2? 3, right? Because that's going to be the filled in one. This one is empty. Does the limit exist? No. Why? Left side does not equal the right side. Guys, that is the easiest and most succinct way for you to say it, especially those of you that are going to be writing the AP test. But even if you're just writing them for me, like, don't write me a novel. You will not get full marks if you write me novels for justifications. Make it succinct. You can be a little bit more wordy than that, but don't write me a novel, okay? All right. Let's keep it going. Based on what you've seen so far, does f of a have to be defined in order for the limit of f of x as x approaches a to exist? Do we have to have the function defined for a limit? No, we do not, right? Otherwise we wouldn't be able to take a limit at an asymptote. So clearly we don't need to. Draw and explain 2 different graphs to justify your reasoning. I don't really have room there. It kind of like bunched those up, didn't it? Let's just do this. I didn't realize that it kind of pushed these things up into here. So we'll do it down below, okay? In both graphs, f of a should be undefined, but in one graph the limit exists, and in the second one it doesn't. So let's just go down to the bottom of the page there and we'll answer it here because it shifted everything up on us. Is yours like that too, or is it just mine?
No.
It is yours as well? Okay. All right, I need to go fix this lesson apparently. All right. So let's draw a couple of graphs here. So we'll draw those in. We were supposed to do one where it was, well, they both had to be undefined. One of them, the limit existed. One of them, they didn't. So let's do does not exist first. We're going to make a limit that doesn't exist. Do it in another color so it makes it easy for you. Let's do an asymptote. Because why not? Let's do an asymptote. If I want this to not exist, where does the right side need to go? Down. Exactly, right? If it goes up, it would exist. So we need it to not exist here. Okay? So here we've got that f of a does not exist. And also the limit does not exist. So if we want to make that different on this side, do you guys want to do an asymptote, or should we switch it up and do a point to discontinuity? Point to discontinuity? All right, so we'll do something like this. Okay? Where in this, and I guess we'll have to say that this is a. So if we look at that then, f of a does not exist. Remember, that's not 1. It's DNE, does not exist. But here, the limit exists. We could even give it a value, I guess. Let's say, I don't know, 1, 2, let's say this is 4. So we'll say that the limit equals 4, right? It's just going to be whatever that y value is. Because from both sides, we approach the same thing. Make sense? Good? Of course. I'm assuming you mean more than a second, though. Who doesn't understand? Who's saying that?
I don't understand what's said right
f of a does not exist, D and E.
Oh, okay.
Did you not do the practice yesterday? Or last class? Yeah, I didn't have you yesterday.
But I didn't understand that we don't think
So did you
it's
just,
like a
you were just telling all of your classmates that they were wrong every time they said does not exist? You were like, no, it's 1. I thought we went over this last class.
Ya es lo que donde no existe se ve como Juan hace como 3 clases conmigo.
All right, are you guys done? Can I go back up?
Yes.
Pertuse is ready. That means we're ready. We're moving on.
Yes.
All right.
No?
So you guys, this is another way that we're going to look at these, or we're going to see them, where we don't have a graph. Because I'm not going to lie to you. Usually, if I give you a graph, other than this very first unit, I am not going to ask you about that graph. I'm going to ask you about a different graph, or I'm just not going to give you the graph at all. I'm going to ask you questions about it. Because that's the whole point of calculus, that we can do it that way. Okay? So this is much more like I guess, realistic of what you might see. Okay, so table questions. I love table questions because they make sure that you guys actually understand what's going on without having a graph. And you can't really construct the graph easily from this either. Okay? So if we look at this, the limit as x approaches negative infinity, that is a negative, it doesn't look like it, but it's negative infinity of f of x. Here's our f of x. If we're going to negative infinity, we're going this way, right? What do you think is happening? Where is f of x going to? Positive infinity, right? We look at it, 3, 9, 33, 513. It's going to go to infinity, right? Or at least that's the best that we can say with the information we have. We could be wrong, but that's probably what's going on. All right, let's look at B. As we approach negative 3. Now, it doesn't specify a side, so we're trying to approach it from both sides here. And the very first thing we should always do with a limit is just literally check. Assume that like it is there. So if I just look at negative 3, what's my value?
9.
Yep. So I didn't even need calculus for that answer. Right? That's like a pre-calc answer. It's great. All right, now what about if we get closer and closer to 1 this time? So we're getting closer and closer to this. 1.5. You guys got it. Now what about our right end behavior? We're going to have x go to infinity. We're going to go to the extreme right. Where are we getting to? No. No. 1. Yeah, you guys got it, and Jack as well. Yeah, exactly right. Because if we look here, we're at 3, 1.5, 1.125, 1.002. So what would be the best prediction is that it's getting to 1. There's a horizontal asymptote there. Okay? All right. Oh, sorry. You guys done? Can I move down? Yes? All right. Let's take a look at the next one here. Do the same kind of thing, but this one is probably an even better question. It's more realistic of what you're going to see. So this time, again, we're going to look at our left end behavior. If we go to the extreme right, or sorry, extreme left, negative infinity, what is the limit as x approaches negative infinity of f of x? Not negative 1, right? Because we got, yeah, because here we're at negative 1,000 and we're at 1.02. It's probably going to 1. All right, for B, we're going to approach negative 1, which is undefined. So this time we can't just look at it. And we want to come only at it from the left side. So if you look here, this value is really close to negative 1. Would you agree? Like we got negative 1.001 or 0001. No, 001. Whatever. Either way, it's really close is the point. So it's really close, and we're at 2001. So where are we probably going? I would probably say we're going higher than that, but sure. Let's go with 2000. With the information we have, we'll say 2000. You could make an argument for infinity as well there. I would probably accept either in this case, okay? Because it's close and you're at 2000, but if you're even closer, maybe it's 4000. This one doesn't really have enough information for us to be more accurate, so that's why I'd accept both. Okay?
Can you repeat it?
Okay, in this particular case, I would accept,
Are you going to repeat B?
yes, I would accept 2000 or infinity. Why? Because the only information we have is that at negative 1, it's undefined. And a little bit before that, it's at 2000. It might be approaching 2000, but it might be at like infinity if what we would need is another piece of information. Like let's say we had negative 1.1 and it was at 100. Well, then we'd say, oh, it's probably actually going to infinity because it's like quickly jumping up, right? If we had negative 1.1 and it was at like 2000.5 or something like that, we'd say, oh, it's going to 2000.
Why is it positive?
Because it's 2001. If it's going up to, if it's at 2001 already when it's just a little bit to the left. Now, realistically, which one's the better answer, do you think? 2000 or infinity? Because I would accept both for you guys at this point. By the end of this unit, I'll only accept one.
I'd say infinity because it just keeps increasing, but it'll never reach.
Because why in particularly, do you think?
What?
Why do you think in particular?
Because -1 is an asymptote, so you get another term.
Yeah, we don't know for sure, but this is probably an asymptote. It could be a point of discontinuity. Again, we don't have enough information. So I would say that most likely infinity is the better answer because at an asymptote, it has to go to infinity or negative infinity. See what I mean? So 2000 is not wrong because it could be a point of discontinuity, and so it could be 2000. But I would probably make the assumption infinity is a better answer. But I would accept both. Do you understand why it's the better answer or no?
Yes.
Yes? No? Do you understand why that's the better answer? No. So the reason it's probably a better answer is because there's two options here. Either this graph is going like this, it's undefined, and then it picks up way down here at negative 2000, or it's an asymptote and it's going like this. That is probably more likely the case. It could be a point of discontinuity, but this, like in most graphs that we're dealing with, an asymptote's more likely. So that's why I'm saying infinity is the better answer, but with the information we have, 2000 is correct. Like I can't mark it wrong because we don't have more information. All right, now let's look about -1 from the right. And again, there's probably two answers I would accept here. What are those two answers going to be? Negative infinity or?
Negative.
Exactly. Again, because we don't technically have enough information. Negative infinity is probably a better answer, but with what we have, I have to accept both because it is possible that it's a point of discontinuity. All right, next one. F of x approaching 2. And we're approaching it from both sides this time. So in this case, what are we approaching? Well, we're approaching undefined, but undefined is what it is. What are we approaching if you look on the left and right? So we're close to a third, right? So in that case, I know for sure now, what is that one? Is that an asymptote or is that a point of discontinuity? It has to be a point of discontinuity, right? Because points of discontinuity can approach a number, and asymptotes have to approach infinity or negative infinity. They have to. Okay?
And it's, do you know also because the numbers are so close to each other? Like,
Exactly, yeah. We can see here this is like this is literally a third, and this is a little bit bigger than a third. Yeah. All right, now we're going to go to the right. We're going to go to the extreme right, do the right end behavior. We go off like that. What are we getting close to? 1. So it's got that horizontal asymptote, right? Usually if there's a horizontal asymptote, both sides go to it. Not always, but usually, right? Limit as x approaches -1 of f of x. So now we're approaching this from both sides. If we're approaching it from both sides, if you look up here, what did we get? Did we get the same answers?
No.
No matter which way we looked at it, we got two different answers. Therefore, this is undefined. You're correct in saying it doesn't exist. Usually we're going to say,
Could E be?
you know, yeah, let's use does not exist. I like writing 1 and confusing you all. Does that make sense to everybody?
Right, that problem it could also be positive infinity.
Which one? This one?
E.
E?
Yes.
I mean,
Or no.
probably not because we're already at, we're at 1,000.
So if you put the other answer is wrong.
Yeah, in this case, it would not be. No, like I wouldn't mark infinity right for that one.
Sir,
Yep.
are you predicting that at x equals -1, it's a vertical asymptote, and the other undefined? It's a horizontal.
No, so this one here, I'm saying this is probably a vertical asymptote. It may not be. The horizontal asymptote is because of these two. When I look at the end behavior, they either like diverge up to infinity, diverge down to negative infinity, or they converge on a number, and that number is a horizontal asymptote. In this case, since both of them are getting close to 1, there's probably a horizontal asymptote at 1, right?
Can you sketch how it looks in a graph?
Yeah, yeah, I guess I can.
I don't understand.
Okay, so it's going to go like, let's see, up like this. Well, let's say it is an actual asymptote. Let's go with an asymptote. Now, don't sketch that because it's not great. But basically the idea is there's some kind of asymptote here that's horizontal. We predicted there's a vertical one here, and then there was a point of discontinuity here at 2. So this is 2. This would be at -1. This would be at like y equals 1. That's why I'm going to do this stuff later, so I don't want to do a bunch of that, okay? But since Matthias asked, I wanted to quickly show. We're going to do a whole section on like sketching later, man. Okay, we'll do lots of sketching later. So I wouldn't worry about if that sketch doesn't make sense, guys. But that is an example of what it might look like. All right, graphical analysis with the limits. So now we're going to look at this graph, and we're going to do the same kind of thing. So the limit as x approaches -3 from the left. -3 is my asymptote. From the left, what do I go up to here? Positive infinity, exactly. All right. Oh, weird, I got 2 C's. Oh, well. B here. So now we're going to approach -5. Since it doesn't specify, we're going to do it from both sides. So -5 is right here. From both sides, what am I getting closer to? 4. Next one.
I didn't understand that.
So that one is just asking for the limit at -5. Since it doesn't specify left or right, it's from both sides. From the left, I approached 4. From the right, I approached 4. Therefore, I'm approaching 4. Okay, because both sides are the same. Now for C, I'm going to approach -1, which is right here. And in this case, the function's defined. It is there. So what is it? Yeah, it's just -1, right? I don't need to find left and right, because if the function's defined and continuous, then it's just whatever that function value is. So here, it's just going to be equal to -1. Now I'm going to look at -3. Well, that's the asymptote. So we would need, well, it could. The left side went to infinity. What does the right side go to? So now it doesn't exist. Yeah. We can't just assume that it doesn't exist. But in this case, yeah, it does not. Does not exist. It says to state why. Left side doesn't equal right side. You really don't need to say more than that, guys. That is sufficient. All right, now we're going to look at approaching 2 from only the left. So up here, exactly. 2 from the left is only 1, right?
Why is it not 6?
Because that would be from the right. Right? This would be approaching it from the right side. So because we're approaching from the left, that's why it's 1. I think we literally do that next, if I remember right. Yeah, so now we're going to approach it from the right, which we just talked about. What is it? 6. And so now, if we the left is 1, the right is 6, now it asks us for just the limit at 2. What do we know? Does not exist, right? Because those two things were different. The left side does not equal the right side. Now the last two, we're going to look at end behavior. So we want to know what happens when we go to the extreme left. So as x approaches -infinity. As we go to -infinity, what are we getting close to here? 2. So we're getting close to that horizontal asymptote. Now we want to check the right end behavior. So when x approaches infinity. Now this time, because it's a piecewise function, we're not actually getting to that horizontal asymptote. What are we getting to? Positive infinity, right? If this is just going to keep going up, it's going to go up forever. So we're going to get to positive infinity. Awesome. All right, got one last set of practice here. And then I'll give you guys some time to do the practice problems. All right, so here we got another graph, another piecewise function. And we're going to take a look at these limits. If they don't exist, state why. Why do they not exist if they don't? What's always the reason?
Left side doesn't equal right side.
Exactly. All right, so we're going to do the limit of g of x as x approaches -3 only from the left.
2.
Yep. It is 0, right? We can see there we're getting close to 0. Let's skip down and let's do D. Okay? We're going to do D because this one is approaching it from the right-hand side this time. Okay, so it's the same number but from the right. And if you look up there, where are we approaching from the right? Still 0. All right, now we'll jump back up and do B. I just thought we might as well do those two together since, you know, they're the same value, or we're approaching the same value. All right, the limit of g of x as x approaches -6 this time. So as we get to -6, we can see here, is it continuous?
No.
Yeah, right here it is at negative. It's not continuous here when we get to -4, but at -6, this is continuous, right? So it means it's just whatever that value is, right? Like if I approach this from left and right, it's just going to be whatever the value is because it's continuous here. So it's going to be -4. Do you guys see that? We're okay with that one?
Yes.
Good. All right, now what we're going to do is we're going to approach -1 only from the right-hand side. -1 from the right. What are we getting to? 2, exactly. So you can see here, like, if the function's continuous and defined, we don't even really need limits, right? It's just the same as what the function is. What limits let us do is figure it out when it's discontinuous for some reason. That's what it helps us with.
And it also, like, for example, in that one, it doesn't matter if it's left or right.
Yeah, exactly, because it's a continuous function that's defined at that point. So you're right, left or right would be the same. All right, now we're going to look at 4. Let's do these ones at the same time because it asks us for the left and then it asks us for the right. So let's look up and do them at the same time here. So we're approaching 4 here. Now let's do the one from the right first. It's plunging down here. Where's it going? Now from the left, don't answer. Look at it carefully. What is going on? It stops. There is no function, right? The function doesn't exist from 3 to 4, right? It doesn't exist at all. So that means, therefore, that the limit won't exist. This is the only time that a one-sided limit will not exist, is if there literally just isn't a function there, okay? If the function exists, it'll exist. If there is no function, that's the only time a one-sided limit won't occur. So in this case, this does not exist. And instead of our answer being like, you know, left side doesn't equal right side, this time it's there is no function. So no function from 3 to 4, right? There's just no such thing as a function between those 2 points. And the right-hand side, it did go to -infinity. Now, because of that, what do you think is going to happen when we look at the limit at x equals 4? So now from both, it doesn't exist, because as soon as 1 doesn't exist, it doesn't exist. So this also doesn't exist. Now, in this case, you could say left side doesn't equal right side, because at this point, we're talking about a normal limit. And it's true that the left side, which is undefined, doesn't equal.
For that one to exist, both functions need to go to the same.
Yeah. So if they were both going to -infinity against that asymptote, then it would exist and it would be -infinity.
Okay.
Yeah. All right, now we're going to look at -4 and we're going to go from the right and left. So at -4 here, that's this point here. I'm going to switch colors because it's kind of hard to see here. So from the left, what am I getting close to? And from the right, I'd probably say -2.5. Yeah, probably -2.5. So from the right, it was -2.5. And from the left, it was, I already forgot. What was it? -6. -6 from the other side. There we go. It was -2.5 from the right and -6 from the left. Does that kind of make sense? We're feeling good? All right, guys. At that point, then, we've just got a bunch of the practice problems here for you.